Very good evening to one and all present here. Today we are going to discuss about transportation problem in operation research. So this is my proposed agenda for today's lecture. First, let us go with the concept definition for transportation problem. So in general, what do you mean by a transportation problem? How this practical the model can be explained using the quantitative mathematical model building approach. So these are the things we are going to see in this chapter. So first of all, transportation problem can be better explained in a possible way by minimizing the cost function. So what do you mean by the term called cost function? It is defined as the amount of the resource that has been spent on the logistics provider for transferring the items from production or supplier place to demand place. So here we want to minimize the cost function in such a way by safely transferring the items between the two places, supplier to demand places. It also consider the distance between the two locations, supplier and demand location, and the path followed between the two locations. Mode of transportation to be fixed between the two locations, say supplier and demand location, a number of units that are transported, and the speed and efficiency of transporting the items between the 2 points. So the overall theme of transportation problem is to minimize the transportation cost of shipping the item without getting any compromise between the supply and demand. Both supply and demand should be well balanced in nature. And what are the objectives of transportation problem? So first of all, the transportation problem can be solved mathematically by using an approach called linear programming model. Here we can fix the objective by considering minimizing the cost of distributing the product from the given number of resources to the number of destination. This is the primary objective for the transportation problem. Based on the number of available resources at destination, we can make an attempt to reduce the cost function between the two regions, source and destination. And the transportation problem deals with moving a commodity that can be a single product from the origin point, that is source, we can say supply or capacity center, how much material the products you are going to supply. So that is the starting point, source, and n number of destination, final ending node, we call that as a sink or a demand center, collection point. Okay, so these are the two main things to be considered in this transportation network in operation research. And it is basically considered that the level of supply at each source and the amount of demand at each destination are known well in advance. The unit transportation cost from each source and destination are considered to be a known variable. Objective is to determine how much amount of the material is to be shifted to each source and destination. By doing so, what is the minimum reduction in the total transportation cost? So here we will try to have the mathematical expression for the transportation problem. So these are the list of variables as followed here. Let us assume that there are m sources at n destination. And A be the supply at source I, and the Bj be the demand at destination j, and Cij is considered to be the unit transportation cost from source I and destination j, and Xij be the number of units to be shifted from source I to destination j. Then the transportation problem can be expressed mathematically as given below. So consider the objective function. Minimize z is equal to double summation. I varies from 1 to m and j varies from 1 to n. So where I is said to be the number of sources and n is said to be the number of destination. So Cij is considered to be the cost function and Xij is an unknown decision variable. So these are the things in which we have to add in the main objective function. Objective function is of the type minimize category. Subjected to following resource constraint. Equation 1 represents supply constraint. Summation of Xij is equal to Ai. This represents the supply source. And next equation, summation of Xij is equal to Bj. It represents a demand constraint. J varies from 1 to n. And followed by the non-negativity constraint. Xij is equal to greater than 0. So this is the general structure of the mathematical model for transportation problem. A linear programming approach model as illustrated here. And the equations are explained in the next slide. The two set of constraints are given here, constraint number 1 and constraint number 2. So this can be explained in such a way. If the two constraints are said to be well balanced, consistent, say for example, if the number of supply is equal to the demand, then it is considered to be a suitable, sufficient problem for solving the feasible solution. Hence, we call this as a balanced transportation problem network. Otherwise, if the supply is not equal to demand, then it is said to be the unbalanced transportation system. Now let us go with the problem illustration framework. Here the numerical problem is given as a case study to explain how we can able to solve the transportation problem using northwest corner cell algorithm approach. Consider the following transportation problem involving number of sources and number of destination. Here there are 3 sources and 4 destination. The corresponding cell entries in the table that represents the unit cost of transferring the item between the source and destination. And these are the demand and supply point that are given in the table. Say for example, cell 1 that represents 3 units of item shipped from source 1 to destination 1. Likewise, in each row, we can read the number, say 1 unit of items to be transshipped from source 1 to destination 2. And for this cost of unit cost of transportation, the total demand and supply point are fixed. So how we can able to find out this whether the problem as a unbalanced transportation model or a balanced transportation model. Add the supply value and the demand value. You have to get the same number. Say for example, if I'm adding the column 300 plus 400 plus 500, 1200, the same number should be getting. Here row demand values 250 plus 350 plus 400 plus 200. Same demand value we have to get it. So if you add row and column, same number we have to get it. And then only we call this as a balanced transportation model network. So in this type, it is considered to be a well-balanced transportation system. Now, we are going to obtain the optimal basic physical solution with the help of the algorithm, say northwest corner cell method. Now, we are going to see the solution manual for the above case study. So let us take column 1 and row 1. Compare the supply and demand value. Here the number of units to be supplied is 300 and projected requirement availability is 250. So which of the uh, find out the minimum value out of the two, supply and demand. So 250 is the minimum. So demand is less compared to the supply. So allocate this number into the cell entry 1 comma 1. That is 1 comma 1 that represents row 1 and column 1. Okay. So here the explanation has been given. So consider the supply and demand value corresponding to the northwest corner cell 1 comma 1 or 300 and 250. These are the value. 300 is the supply and 250 is the demand. So here the minimum value out of this two number is 250. Hence, project 250 unit to the cell 1 comma 1 and subtract the same value from the supply and demand value in the entry 1 comma 1. Okay, right? So we want to subtract the same number 250 minus 250. The demand will get 0. 250 minus 300 supply out of 300, the remaining value will be 50 units. So the total amount of the supplying the material from source to destination, it was 300. Now we have subtracted 300 with the minus 250. So the balance item to be supplied is 50 only. So now here the demand is completely met out. So we have to delete the column 1. There are nearly 4 columns. The column 1 has been deleted. So in this approach, either row or column, anything should get 0. So in order to eliminate the particular column. But here, the column 1 cannot be further satisfied because the demand is ultimately utilized very successfully. So it has become 0. Now, remaining 3 columns and 3 rows are there. So in the next iteration, okay, according to the steps of algorithm, so compare the supply and demand in the second iteration. So here the supply is 50, demand is 350. So the minimum number is 50. Supply is less compared to the demand. So hence allot 50 units into the cell 1 comma 2 and subtract the same value for demand and supply. So 350 minus 50, 300 is the required demand and this is considered to be 0. 50 minus 50, 0. So totally eliminate row 1. So here the supply is completely matched. And now we have only 2 rows and 3 columns in the next iteration. So this is the continuation of the third iteration. So once again, okay, so consider the supply and demand, compare here 300 and 400. So demand is less compared to the supply. So allocate 300 into the cell 2 comma 2 and subtract the same value for both supply and demand. So 300 minus 300. So here the demand is completely 0, satisfied. So 300 minus 400, you will get 100 here. So the remaining amount to be shipped is 100 out of 400 by subtracting 300 units. Okay, so now we have to delete column 2. So remaining 2 columns and 2 rows will be continued to occur in the next iteration. So again, here also, just compare the supply demand value according to the northwest corner cell approach, 400 and 100. So 100 is the minimum number. So allocate this value into the cell 2 comma 3. Okay, then subtract 100 for demand and supply. Here 400 minus 100, 300 will be the demand, and here completely this will become 0 supply. So delete the second row. Okay, so in the next iteration only one row will be there and two columns will be existing to occur, the last iteration. Okay, so 300, supply is 500, demand is 300, so minimum is 300 demand value for the cell 3 comma 3. So fix 300 into the cell 3 comma 3 and subtract 300 along with respect to the supply and demand. So this will become 0. Okay. 300 minus the next one, 200 and 500. Next, compare the demand for the column 4. For the column 4, uh, here it was 200 and supply is 500. The minimum is 200. Okay. So here also we are meeting the demand in column 4. 200 minus 200, this has become completely 0. Now you add these two values, 500, 300 plus 200, 500. Okay, so already here supply 500 is there. So 500 minus 500, totally 0. So now we are eliminating row and column. Okay, so it is a balanced transportation model. So this is the last iteration of the problem. Then now we want to find out the total the cost, that is the basic feasible solution. So consider the table, enter all the unit cost of transporting the item between each source and destination and the allotted supply demand the values in the corresponding selected rows and columns, and find out the total cost. Total cost is equal to number of units, uh, the cost of unit cost of items to be shipped between source and destination multiplied by uh, the amount of unit to be supplied. Okay, so you add all the value, say 300 into 250 plus 1 into 250 plus 6 into 300 plus 5 into 100 plus 3 into 100 plus 2 into 100. So add all the value by considering the unit cost of transporting the item by multiplying with the allotted the supply demand value, so that you will get the total cost of transportation rupees 4,400. This is the minimum cost of transporting the item from all source to the various destination point. What are the common application of transportation problem in operation research? So this quantitative model can be applied in practical scenario like stock keeping inventory control system for matching the supply demand, and production planning in machine shop, in production scheduling, even manpower recruitment, personal allocation, human resource management system. So these are the different places of implementing the concept of transportation problem. And finally, I will end the lecture with the conclusion, closing remark. So we obtain an optimal solution with the help of the northwest corner cell algorithm. The purpose of transportation problem is to transship the item as per the given supply and demand constraint. So once again, I thank all of you for your patience listening. So in the next class, we will meet with uh, production scheduling problem in operation research. So once again, I thank each and every one of you. Thank you all.